Hi there, kiddos. It's always an exciting day when I'm making a video. Okay, we're doing lesson 8 in module 3, and we're just past the mid-module assessment if your teachers gave it to you. Sometimes, because they're only like 16 lessons, it's like, let's just blaze through and get it all done. But lesson 8 kind of has a little shift. We're working more with mixed numbers, and we're going to be using the number line to add and subtract fractions. You still have to make equivalent fractions before you can start working with the fractions themselves, but the whole numbers can make things kind of easy. So very important, looking at the objective, our strategy is to use the number line and equivalence, because you can't add and subtract without having equivalent fractions. But the number line is really going to help you a lot. Now, most important thing for today, watch the signs. Normally in a lesson they say, today we're adding or today we're subtracting. But life isn't like that. Life doesn't come with a, you're only going to add today. No, it is adding and subtracting all day long. First one, then the other, and you never know what's coming. So just get in the habit of watching the signs. Every problem is independent of the next. So how do we do this? It's super fun for the addition and very easy. Whole numbers get combined. 1 plus 1 3/4. 1 plus 1 is 2. It's as easy as that, plus 3/4. On a number line, it looks like this. 1 plus 1 plus 3/4. Very straightforward, very simple, nothing confusing. 2 3/10 plus 3, 2 plus 3, there's your 5, and then add the fraction. It's not the addition that's a problem, it's the subtraction that tends to throw people off. So for subtraction, remember, you're starting at the whole. This first number is the whole. It is the top of your number line. You will not go above this. You will start at the whole and you will go down the number line. If you have a vertical number line, you will literally go down. You're going to take away the fraction that they say, so minus 1/4. So take away out of the 4 parts. You have to do a really good job creating your number line up to the whole so that you have appropriate parts to take away. 0/4, 1/4, 2/4, 3/4, 4/4. From 1, take away 1/4 and end up at 3/4. When you have a whole number like 2, start at 2. And subtraction, as you can see right here, it's going to move you continually down the number line. So when you take away 3/5, that is still going to give you something that's higher than 1, but less than 2. If you divide this into fifths, you'll go 1, 2, 3, taking away 1/5, 1/5, 1/5 for a total of 3/5, which will leave you at 1 and 2/5. Okay, now what if I take away a whole number and a fraction? Well, jump on the number line for the whole number, then continue in the same direction because we're still subtracting this much more. So subtract another 2/3. So divide each of these pieces into thirds and then you can take more away. Okay, so that's that. This is kind of more of the same thing with the same problems, but sometimes I'll have like little notes that are handy. Oh, but if it's blurry, that's not helpful. I like the eyes. Watch out for subtraction. Truly, watch out for subtraction. So pull that book out and let's get ready to make some number lines. Add or subtract. Keep an eye on the signs. 2 plus 1 1/5. Now, again, it's not that it's hard. It's just being precise. 3 1/5. So make a number line. Yes. Do you have to? Yeah, probably. And if I'm going to go higher than 2, I'm going higher than 3. This is extra. So I'm going to have it 0, 1, 2, 3, 4. And look at this part. This is a clue. The denominator is going to tell you how many parts to divide each whole into, but I don't have to divide the entire number line into parts. It's only the little fractional unit where I will end up. So it's all of the 2 plus all of the 1, and now I can make fifths. 1, 2, 3, 4, 5. Here would be the 5 fifths. And then I have 1/5. Plop. And so this is 1/5. And so it really, I mean, it's very straightforward when you're adding. Subtraction, we're going to be moving this way. So draw your number line. 2 will be the highest value. We're going to start from here and go backwards. We're going to take away a full 1, and I don't need to divide this into eighths. The 8 is the clue for how many pieces to separate this into. But now that I have nothing but a fraction to take away, I'm going to create eighths. Okay, so now I have 8 parts, and I need to take away 3 of them. 1, 2, 3. So what am I at? I don't have any labels here. So if each one of these is minus 1/8, oops, blending in, minus 1/8, minus 1/8, and this is 1/8, 2/8, 3/8, 4/8, remember that's halfway, 5/8 is what comes next. And so when you do your subtraction, if I take a whole 1 away, and then I am between 0 and 1, I no longer have a whole number. I'm only at a fraction for my answer. Okay, and so that's what it's 0 and 5/8. Okay, so addition, again, really easy. 5 plus 2 equals 7. But now I have some fractional units that I have to also consider. Because what if I go over or past my whole number, which it's very likely. So let's make a number line and see what's happening here so I can make sure I have the best answer possible. 1, 2, 3, 4, 5, 6, 7, 8. Let me go to 5, 6, 7, 8. Let's go from 0 to 8. And start with your, I have 5 and 2/5 plus 2 and 3/5. And again, they have a common denominator, so I can combine them. And I have 5 and 2. So I'm going to use my whole numbers first. So I'll go 0 to 5, and then from 5 to 7. So this is plus 5, and this is plus 2. But now I have to consider these two fractions. So the 2/5 plus 3/5 actually makes 5/5. So this part here, 1, 2 plus 1, 2, 3 gets me up here to my 8. And so it's past 7 all the way to 8 because my fraction pieces make up one more. Or you could put 7 plus 1 equals 8. Okay? So that is your answer. This one or this one. 4 minus 2 and 2/7. Again, once you start going down the number line, you're going to continue going down the whole time. So 0, 2, 4, 1, and 3. Starting at 4, take away 2, minus 2. Now I also need to continue taking away 2/7. So divide this into 7 pieces. 1, 2, 3, 4, 5, 6, 7. The 7 or the 7th piece is going to be the hash mark that's already made for the whole. It's kind of like when we do our fraction models and I say, oh, only make 6 lines for 7 parts. That's the same here. So each 7th can be labeled from the whole number. 4/7, 5/7, 6/7, 7/7. But I need to take away 2/7 more. 1, 2. Each one is minus 1/7, or if you want to do minus 2/7. Okay, so just show that you're taking both away, and you end up right here at 1 and 5/7. There's another activity that's really good. It's a fluency activity, and if your teacher runs it, it's great. It's making a whole out of a fraction. So like counting onward or knowing what's missing, so that 2 2/7 needs 5/7 to get up to the next whole. So look at what these fractions are made out of. It's kind of an important, it's an important piece of knowledge so that you can build your number lines correctly. Okay? All right. Sorry if that was off the page previously. I still don't know how to edit my videos. It's like, okay, this better be good in one shot or else that's what it's going to be like forever on YouTube. And again, I hope these are helpful. If it's helpful, click subscribe, and you can be entertained every day as I mess something up, guaranteed. Anyway, just kidding. I'm trying not to mess up, which is sad when I do mess up. But 9 plus 8. Now, do I really have to number all these things on the number line? No, you don't. Thankfully, just start at 0. That's the one thing you really do need to have. And you can just go like this. 9. Okay? You can have like, put some hash marks and count every other. You can count by thirds. You can put another one here and just go plus 8. Okay, and it's kind of like art. You don't have to show every single thing to get the point across. Okay, and so what would be here? That's the important thing. If I add 8 to 9, this is going to be at 17. And once I get past that, that's just my fractional value. My answer is 17 3/4, because when you have a fraction and no other fraction, that it just gets tacked right onto the end there. So easy peasy, that one's like the easiest one. And in the same way, when we're subtracting from a large number, just put that at the end. And you don't always have to have a 0 for the subtraction problems, because you may not be anywhere close to 0, especially when we get up into the larger numbers. So if you take away 15, that's quite a lot. Okay, so I am getting pretty close. But if I subtract 15, you know what you're going to be at. This is at 2. But I don't label this whole number here 2 because I'm taking away more. So even if this is 2, I still have to go to the left, which is between 1 and 2. Okay, so with subtraction, my whole is broken into thirds, and I'm taking away 2 more of them, which will leave me at 1 1/3. Okay, so just be really careful. Continue going down in the same direction on the number line. Addition, kind of using the same numbers. They must have had a happy time with 15 and 17. Let's keep using that. So again, you don't have to label every single thing on the number line. You can just say, oh, that's about 15, and guess what? That's about 17 more. But we can't stop here, so you can label this point as 32, and you don't even have to put the +1, but the next one. Okay, we've got 2/3 between 32 and 33. 1, 2 plus 2/3. And so it's going to be 32 and 2/3. Okay, just being really careful about how you show that. Now, again, here on the number line, do I really have to number everything to 100? No, you don't. Just put 100. And then I'm going to take away 20, minus 20, big jump there. So this would be at 80, but I have to take away more. So if I put 79 here, and it does not have to be spatially the same, like, you know, you can see that if this is 20, clearly this can't be 1, but what I want to show would be the 8 units in between, so that I can take away 7 of them. Oop. There's my 7/8. And so what would be left, what makes the whole 1/8? So 79 and 1/8. Okay, sorry I didn't circle all the answers. That's okay, we will survive. All right, I hope that's clear. And then we have 3 word problems. Calvin's in timeout. Calvin had 30 minutes in timeout. That's a long timeout, I just want to say. For the first 23.5 minutes, Calvin counted spots on the ceiling. Oh, what an exciting way to spend your time. For the rest of the time, he made faces at his stuffed tiger. Calvin and Hobbes. How long did Calvin spend making faces at his tiger? So we've got our whole amount of time. We have a part of the time that's identified, and then we have our left, the rest of the time. Okay, so let's make a number line and take our whole, set it up, 30 minus 23 and 1/3, 30, and we're taking away 23. And if that, and don't put 23 there, we're taking away 23, so you have to do the subtraction, or what's the difference between 23 and 30. So the difference is 7. Okay, then this is 7, but I still have to take away 1/3. So put your next one down, label 1/3, 2/3, this is the 3/3. Take from the 7, take away 1 more third. Now I've taken away 23 and 1/3, and I end up at 6 2/3. And minutes, how long did he spend? Minutes making faces. Okay, just be specific. There you go. And then we can move on. Okay. Lights went out. Even though I jogged around before I got started, something always happens, and then it's not in focus. Super annoying. What else is going to go on today? So exciting. Linda planned to spend 9 hours practicing piano this week. By Tuesday, she had spent 2.5 hours practicing. Okay, this is her plan. Then she had spent some time. How much longer does she need to practice to reach her goal? I always think of the tape diagrams. If this is the whole 9 hours, and she already spent 2.5 hours, this is the how many hours. That's just the way I see it. So I always like to, as it says for the word problems, read, draw, write. I like to draw something. But our goal is to take the 9, take away the 2.5 that she already practiced. So on your number line, if you have 9, remember that's at the top, and then you take away 2, that would give you 7. But don't put that as your answer, because, and there's 6 and there's 5. I don't have to go too far. I have to divide each into the denominator number of pieces. The denominator tells you how many pieces, and I have to take another half away, minus 1/2, which leaves you at 6.5. So when you first look at these problems where you're taking away a whole number and a fraction more, you may initially look at this and say 9 minus 2 is 7 and put a 7 there, and almost every single time it's going to be wrong. So you have to be thinking about it's minus this and minus more. So if 9 minus 2 is 7, go down to 6 and then find your fraction. So that's just something to be really, really careful of. Big problem over here about Gary. Gary says that 3 minus 1 1/3 will be more than 2 since 3 minus 1 is 2. Draw a picture to prove that Gary's wrong. That's what I was just talking about. So the picture could be the number line. And we can do the whole thing starting at 3. And we have thirds. 1/3, 2/3. 1 1/3, 1 2/3, 2 1/3, 2 2/3. So let's do the whole thing. 3 minus 1 1/3 minus 1 and minus a third. Okay, we have to take away 1 and then take away 1/3. So he says more than 2. No. Draw a picture to prove that he's wrong. I have to take away more. So when subtracting, continue in the same direction. Okay, and that direction is going to be towards 0 or negative, toward negative numbers. And so really the answer is 1 2/3. Okay, so it is not more than 2, it is less than 2. So that's how we prove he's wrong. Not that we love to feel gloating and full of ourselves. We want to help Gary out. So anyway, I hope this has been helpful. That's all there is for lesson 8. I hope you guys have a fantastic day. Subscribe if you like it. You'll be notified when I upload another video. Always fun here in my classroom. Take care. Bye.